Hi, I'm introducing to you the Let's Count on Math negative number line extension kit. With this kit, what we have are the negative numbers. And the negative numbers are indicated in red. They have arrows indicating the direction of travel, so they get placed pointing into the leftward direction. So it's a little bit different than using balloons and weights, for example, which I used when I was teaching grade 7 and 8, because it removes a layer of abstraction or something for the kids to have to remember and interpret. Because with balloons and weights, they have to remember that the balloons are positives, that the weights are negatives, and then that one extra layer of interpretation sometimes gets in the way of the mathematics for some kids. Here, the mathematics are direct. You are dealing directly with the positive and negative numbers. So let's take a look at these 10 typical questions that we want the kids to learn in grade 7 and grade 8 with their integer operations. Question number 1, a negative plus a negative. So negative 5 plus negative 6, we have a negative and a negative. So we explain to them you're traveling in a left direction and you're traveling in a left direction. And that's easy enough to show on this number line because we're going to put the negative 5 here. And we see that we're going in the left, and then we're going to apply the negative 6 as well. And they can see that you end at negative 11. So a negative plus a negative moves you further in the negative direction, so negative 11. Number 2, 7 plus negative 10. We've got rightward movement and we have leftward movement, and that's easy enough to demonstrate again because we have the two different kinds of number strips, a positive and a negative. So the 7 is going to indicate a positive movement in the right direction, and then the negative 10 we're putting from the end of where we just stopped going to the left, and you can see that we're going to end up at negative 3. They can also see from the strips that the negative 10 has a larger magnitude than the positive 7. Therefore, our answer has to be negative. So rightward movement and leftward movement, but the leftward movement is greater. So our answer is at the negatives. Number 3, negative 4 plus 9. Again, two different types of strips, one for the negative, one for the positive. Negative 4, we're going to go and apply to the number line. It takes us in the leftward direction. So we end up at negative 4. And then plus 9, we end up going over to here. We land at plus 5. Again, we see the idea that they are two different signs. So there's a leftward movement, rightward movement. Greater magnitude is the 9. Therefore, we end up with net positive at 5. Question number 4. Here's where we get a little bit trickier because as soon as you start talking about removing things, kids have a harder time seeing that and understanding what it is that we're removing and why it moves the way that it does. So in order to establish this concept, we have to do one thing first. I call this the integer basket. And what I do with that is that it's a basket holding whatever integers I place into it. So for example, right now there's nothing in it, so it's at a 0. But if I put a negative 2 into it, it should move to negative 2. If I then put in a positive 5, I now move 5 to the right. 1, 2, 3, 4, 5, and they can see that we end up with positive 3. Very, very similar to these types of questions here. Not a problem. However, the thing that I really want to introduce using the integer basket here is the concept of 0 pairs. So here's what I mean by that. We asked the class, if I put in a negative 5, where does the basket move to? And they should see that it moves to a negative 5. If I now put in a positive 5 to the basket, where does it move? This moves it back to the right 5. And as a result, we end up at 0. Now we ask the class, what happens if we put both of these into the basket at the same time? They should realize that because these two things are canceling each other out, there's movement, or movement. There's a net 0 movement from putting these two things in, and therefore we call this a 0 pair because we've added it in, but really we've added 0. There is no movement, so the basket stays here. So let's see how that works. Question number 4 is 5 take away -5. So we can start with the 5. That's not a problem. It moves to 5. Now, how do we demonstrate take away -5? Is that we do the following. We're going to take the 0 pair and put it into the basket. And the kids should understand, oh, that doesn't affect anything. We still sit here. But now we're going to remove a -5. And they see that, oh, we just jumped forward 5. Which is why we equate that with 5 take away -5 is the same as add the opposite, lands at 10. Question number 5, -6 take away -7, or -6 subtract -7, whichever way you want to see it. So -6, we're going to apply the -6 into the basket. The kids will see that, yep, that's going to move us to the left 6, so we end up there. And same idea now. We're going to say, okay, well, we want to be able to take one of these away, but there's nothing in there yet. So we're going to take a 0 pair. We're going to put in this pair of numbers together. So -7 and +7 both go into the basket at the same time. And they should realize that, okay, yeah, that's a 0 pair, so there's no net movement. But now I'm going to take away a -7. And as a result, we move to the right 7, 6, 7, and they see that we land at +1. Okay, hence add the opposite. They start getting the idea that removing negatives moves you to the right. -6 plus 7, there's a net of +1 here, which is what we're showing on the number line. Question number 6. 5 times -4. We can use the integer basket for this, or we could just use the number line directly. Basically, what 5 times -4 is we're counting. What is it we're counting? We're counting 5 -4s. So all we're doing is we're taking the -4s and we're placing it into the basket. There's one of them. There's 2 of them. There's 3 of them. There's 4 of them. There's 5 of them. Oh, I ran out of board space. However, I would prefer to not use the integer basket and just use the number strips directly. Because again, there's no translation needed. 5 times -4 means simply I'm going to go and put in, I'm counting 5 -4s. 4, 5 of them, and they can see that we land at -20. Question number 7, -3 times 6. This one we're going to require the integer basket for. We like to interpret it as, I like to interpret it as, remove 3 positive 6s. So we're going to use our integer basket. We're going to introduce 0 pairs because right now there are no -6s or positive 6s to remove. So there's 1 pair. We get no net movement. We introduce another 0 pair. And we're going to introduce another 0 pair. And in question 7, we're removing 3 of the positive 6s. So if I take those 3 away, 1, 2, 3, the kids can see what's remaining are 3 -6s. So we end up with a net movement of -6, -6, -6. We end up at -18. So this equals -18. Question number 8, -4 times -5, or remove 4 -5s. We're going to introduce 0 pairs again, so I have to get out my 5s and -5s. Here's 1 0 pair, 2 0 pairs, 3 0 pairs. Running out of room here rapidly. 4 zero pairs. And since we're doing -4 times -5, we're removing 4 of the -5s. There's 1, 2, 3, 4. I've taken away 4 -5s, and the students can see pretty clearly that there's 4 positive 5s remaining. I'm going to run out of space here, but we're going to be moving, there's 5, 10, 15, we would land at 20. In a regular classroom, of course, you'd have much more board space than I'm limited to here. Number 9, -18 divided by -6. There's a few different ways to look at this. We could start with an arrow pointing at -18 and then say to the kids, in order to get back to 0 from -18, what do I need to put in there relative to this question? Well, 3 -6s. Because what we're asking is, how do we get back to 0 remainders from -18? And because we need 3 -6s to get back to 0, that's why we need 3 of them, not take away 3 of them, but we need 3 of them. -18 divided by -6 is equal to 3. And question number 10, -12 divided by 4 is interpreted as, if we have -12 and we're splitting it into 4 equal parts, how much is each part? So there's our -12, and we're splitting it into 4 equal parts, which means that we need 4 pieces that are the same to make it -12. And those 4 pieces are 4 -3s to make -12. So -12 divided into 4 parts is -3. All right, so that illustrates the concrete way of modeling all of the integer operations with direct strips and no translations of balloons and weights needed. This is a very, very direct interpretation for the kids, and they're using counting as their basis for understanding the integer operations. Thanks.